Hello everyone. In this video we are going to learn how to create a Tetris game in Python using the arcade library. And we are going to use arcade version 3.3.2. You can already see the game what we are going to create. This video is not for absolute beginners in programming. I assume that you already know the basics of Python or any other programming language. If you want to learn more about the arcade library, I already created an arcade tutorial series a few months ago, which uses arcade version 3.x. Originally, I created this game 5 years ago in arcade version 2.3 or 2.4, and I just ported it to arcade version 3 in the last few weeks. I haven't used any AI for creating the game, so no vibe coding bullshit. And also no AI was used to create this video. The code from this video will be uploaded to my Patreon page, and the link to the Patreon page will be in the video description. So okay, that was the introduction, so let's get started with the development of our Tetris game. Okay, in this section we are going to create the arcade window. Of course you have to first install arcade with this command pip install arcade, and in this video I'm going to use arcade version 3.3.2. Although a few days ago 3.3.3 was released, but I'm going to stick with this version. You can use the newest version if you want. So first what we have to do is import the arcade library. The next thing what we are going to do is create an arcade window. So window equals arcade.window, and its width will be 1024 and its height will be 960, and the title will be Tetris game. What I'm going to do next is just center this window. So window.center window, and this will center the arcade window on the screen. Okay, next what we are going to do is create a game view class which will inherit from arcade.view. And I already explained most of this stuff in my arcade introductory series. So an arcade view is a view to a game. You can have multiple views in your game, and you can switch between these views. And this view class has several methods like the onDraw, onKeyPress, onKeyRelease, onUpdate, and so on, what we are going to use later. For now, what I'm going to do is just add dunder init method and also call the superclasses or the arcade views init method. So super and dunder init. And the next thing will be instantiate an object from this GameView class. So game equals GameView. Also call this method, so window.showView, and giving it the GameView, so this. And the last thing what we have to do in this section is just enter the arcade application loop, so with arcade.run. Okay, now let's run this script. And as you can see, we have an arcade window, and its width is 1024 pixels and height is 960 pixels. And the title is set to Tetris game here. And here it is, the title. I'm just going to quickly show you one more thing here. So why I choose 1024 by 960. Here is the prepare game. This is the preparation script. So technically this is the 1024, and I leave here some space for the UI elements, so for drawing the next letter and so on, and also displaying the game statistics. And this will be the playing area. Each of this square or this cell will be the size of 64 by 64, and we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 of these cells horizontally and 15 cells vertically. So 12 times 64 and 15 times 64 vertically. In this section we are going to create the grid class, and the grid class will be responsible for drawing the grid lines and also drawing the letters or the tetrominoes, and also handling the collisions and so on. So technically this will be a two-dimensional list, so a list of lists. So let's start, and I already created this grid.py, and here I'm just going to add first three constants, although technically these are not constants because Python don't have constants. So this will be the cell size, and it will be 64. So this will be size of each of those little squares, so 64 by 64 pixels. Then we have a grid width, so 12 columns, so number of columns, and the grid height 15, and this will be the number of rows. Okay, the next two constants I'm going to set is the grid horizontal size, so grid h, and the grid vertical size, so grid v size. And the horizontal size will be the grid width times the cell size, so this will be 768 pixels horizontally, and the vertical size will be grid height times the cell size, so this will be 960 pixels vertically. And one more thing I'm also going to add is the grid line colors, so grid line color, and this will be set to 255, 255, 255, so red, green and blue, and the alpha will be set to 35. The next two variables I'm going to set is the start x and the start y position. So each letter starts at row 1 and column 4. So start x is 4 and start y is 1. And two more variables, and because these will change, that's why I'm writing them with lowercase letters. So this will stay constant. And this will be the current x equals the start x, and the current y equals the start y. So the active letter current x or column and y position or row position on the grid. Okay, so the next thing what we are going to do is create the grid class itself, and also just call the init method or the dunder init method. And I'm going to create a member variable or a property, and this will be called the self.mainGrid. And later I'm going to create a so-called test grid, and that's why I'm calling it main grid, so to differentiate between the main grid, which is visible on the screen, and we will have a test grid, which is an invisible grid. Later I'm going to explain it in a later section. So here what we are going to create is this method, so cell.create, and this will be responsible to create the two-dimensional Python list. Okay, so let's create this method. So I'm just going to call it create, and this will return a list of lists. And also add a little bit of documentation here. So creates a grid structure as a list of lists. So the first thing, I'm just going to create an empty list called grid, and we are going to loop through the height. So for y in range grid height, which is 15, and we are going to append an empty list to the grid. So grid.append an empty list. And we are going to create an inner loop, so which will loop through the width. So for x in range grid width, which is 12. Here we are going to add an if condition, so if x equals 0, or x equals the grid width minus 1, or y equals the grid height minus 1, we are going to append to the grid at y index an 8. So the 8 will be the walls, grid walls. And else we are going to append a 0. So if I run the prepare game, so all these black boxes or these black cells are empty cells, and that's why I'm setting them to zeros. And all these white, so these are the walls, these are set to 8. So each of these grid cell is set to 8 here. Now let's test it. So I'm just going to add here an if condition. So if dunder name equals dunder main, I'm just going to import the prettyprint function. So from prettyprint import prettyprint, and I'm just going to instantiate a grid object here. So g equals grid, and also prettyprint the main grid. So prettyprint g.mainGrid, and the main grid is set here when we instantiate the grid object. And let me see, so I'm just going to switch back, or I'm just going to directly run this grid.py, so right click and run grid. And of course we get none because I forgot to return the grid. So here in the create method, I'm just going to add a return, so return grid. Now let's run it, and as you can see we have this grid structure, which is a Python list of lists. So here is the first list, the second list, and as you can see where the wall is, everywhere is 8. So these are the walls, and this will be for actually constraining the playing area, and everywhere where you see zeros, this will be actually the playing area. Okay, let me quickly explain how this create method works. So first we are looping through on the height, so we are going from up down, so vertically, and then we are going horizontally, so in the grid width. And here, if x is 0, we are appending an 8, and if x is grid width minus 1, so we are here, we are also appending to the grid at y index an 8. And we are going to the next row, which happens the same, the third and fourth row. So, and if the y is equal to grid height minus 1, so or not and but or y equals grid height minus 1, that means that we are on the last row. So here we are appending only 8, so grid y that append 8. And if this condition is not true, we are just appending zeros. In this section we are going to draw the grid lines. So the grid lines are these lines, horizontally and also vertically. So let's go back to our game, and here in the grid class I'm going to create a new method called drawGrid, or just draw lines. And here, for example, after the init method, so this will be the draw lines, and it returns none. And we are also going to loop through first on the width, so for x in range grid width, and we are starting from 1 and going to grid width. And I'm going to also import, of course, the arcade library here in this grid.py. So import arcade, because we are going to use it here, and we are going to call the arcade the drawLine method or function. So arcade the drawLine, and the first point, which will be x times the cell size, and 0, so the xy position of the first point, and this is the xy position of the second point, so x times the cell size and the grid vertical size. So this will be, cell size is 64 and the grid vertical size is here, so 960. And this is the line color, so grid line color, and the line width is set to 1. And let me call this drawLines function in the game.py. For that we have to import, of course, the grid. So from grid import grid, and here in the game view we have to call the onDraw method. So def onDraw, and this will return none, and here we can call the grid.draw. But first of all we have to instantiate a grid object here in the init method. So self.grid equals grid. And now we can call on the self.grid object or property the drawLines method. Let me run it. And as you can see, now we have these vertical lines. And if I go back to the grid, here the x times the cell size and 0 creates the first point. So this one, for the example, and x times cell size and the grid vertical size creates the second point, so this one. And between these points Arcade draws a line, and this is the second, third, fourth, fifth, and so on lines. Also draw the horizontal lines, and I'm just going to add here a comment that this draws the vertical lines, and here will go the horizontal lines. Here we are going to loop through on the grid height, so for y in range starting with 1 and ending at grid height. We are also going to call the Arcade the drawLines or line function. So Arcade drawLine, and the first point will be at start, x0, and the y will be y times the cell size, and this will be the second point. So the grid horizontal size, this is the x, and the y will be y times the cell size, and this will be the grid line color, and this is the line width. So now if I run it, we have all these grid lines drawn, and here will go the walls, also here and also here, what we are going to do in the next section. There is one more little bug in this. So here I set the grid line color to 255, 255, 255. So this is a white color, and the alpha is set to 35. But when I run the program, these lines are not transparent because we are not clearing the color buffer bit. So it just draws over and over and over the same lines. That's why it is so bright. So let's go to the game file, and here in the onDraw method I have to also do clearing. So between each draw we just going to clear the color buffer bit, so by calling the self.clear, and this will call the method from the arcade.view class, and as I said, it will clear the color buffer bit and also the depth buffer bit. And now if I run it, as you can see, now these lines are much more transparent, so they are just barely visible and it looks much better. In this section we are going to draw the grid walls. So everywhere where the cell value is 8, we are going to draw a white square which will represent the grid wall or the playing area wall. Okay, so let's go back to our grid class, and here I'm just going to define one more method, and this will be the drawWalls method. So drawWalls, and this returns none. So in this method, first I'm going to loop through on the grid height, so for y in range grid height, and then I'm just going to create an inner loop for the grid width, so for x in range grid width, and here we are going to calculate the position of each of those squares. So the square x will be equal to x times the cell size, and the square y will be this expression, so square y equals grid vertical size minus the cell size minus y times the cell size. So this will be the xy position of each of those squares. And now I'm just going to ask here if there is a wall, and soon I will create this method, so getCell. So if this method self.getCell at xy will return 8, that means then there is a wall, so we are going to draw a white square using this function. So let me show you. So arcade.draw LBWH rectangle. So and LBWH means left button and width and height, and this will be a filled rectangle, and its position will be at square x and square y. We calculated those here, and its size will be cell size and cell size, so width and height, and this will have an arcade color white, so it will be white. Let me do this getCell method. So I'm just going to scroll down, and for example after the create, or it doesn't matter where it is, I'm just going to copy this getCell, and this will take two arguments, so the x, which will be an integer, the y, which will be an integer, and it will return an integer. And I'm just going to copy a little bit of documentation to this method. So sets, although I copied the wrong documentation, so returns the cell value at x and y position from the grid. So and x represents the column and the y represents the row on the grid. And so we just returned this. So return self.mainGrid at index y and index x. Okay, and now let's call this function, the draw walls, in the game.py. So cell.grid.draw walls, and let me see it. And as you can see, now we have the walls. Although I'm just going to add one more draw command for drawing the outlines of these walls. So let's go back to the grid, and here in this if condition I'm just going to add one more of these draw LBWH function. So here we will use the arcade.draw LBWH rectangle, but this time this will be an outline. So this was the field, and this will be the outline, and it takes the same parameters, so square x and square y, cell size for the width and height, and arcade color Amazon, and the border width will be set to 2. And now if I run it, as you can see, now we have a clear separation between the cells. I'm just going to add one more method which will draw everything at once, so the draw walls, the draw lines. Later I'm just going to add also draw letters or tetrominoes. And to simplify it, I'm just going to define here one more method in the grid class. So, and this will be the draw all, and this returns none. And here in the draw all, I'm just going to call the cell.draw lines and also cell.draw walls. And let's go back to the game.py, and here instead of calling these two methods, we are just going to call the draw all method. And it works the same as before, but now the GameView class is a little bit simplified. In the previous section we created this getCell method, which takes an x and a y, and it returns an integer. And in this section I'm just going to add one more method which will set the cell values and quickly explain how does it work. So for that I'm just going to create this new method after the getCell, and I'm just going to call it setCell. It also takes the x and the y, so which both are integers, and the value, and this will set the cell value at xy position to this value, and this returns none. And I'm just going to add quickly a documentation to it. So sets the cell value at position x column and y row, although I'm just going to exchange these. So again, sets the cell value at position y, so row, and x column. And I also exchange it here, so returns the cell value at y row and x column position from the grid. And the set cell, here we are just going to set the cell of the main grid, so cell.mainGrid at y, so this is the row, and x, this is the column, so set its value to the value we are passing here in this method. And let me quickly run the application. So if we are getting a cell, for example here, this is the main grid, and so we are returning the main grid at y and x. So the y in this context is the row, each row, and the x are the columns. So in Python, if you want to index a two-dimensional list, but not just in Python but any other programming language, first you start with the row and then with the column. So that's why it is y and x. So from now on we are going to use these two methods, the getCell and the setCell, to actually set the values of cells and also get the values from the cells. And here, if I scroll up in the draw walls, we already use the getCell. So if the cell value at xy position on the grid equals 8, we are drawing the walls. And later we are also going to use this cell.getCell method to draw the active tetrominoes and also the inactive tetrominoes, or the settled tetrominoes or letters. In this section we are going to create the first letter, or also called tetromino, which will be the letter T. So I already created this file, letters.py, and this will hold all the letters. And the first thing I'm just going to do is import the color module from Arcade. So from Arcade import color. And I'm just going to add a little bit of a comment here. So this will be for the letters or tetrominoes. And the first letter what I'm going to define or create is the letter T. And each of these letters will be a Python dictionary. So the letter T has 4 rotations, and I'm just going to create the first key value pair for the first rotation. So this will be, the key will be 1, and this will be a two-dimensional Python list, and this will represent the first rotation or the default rotation of the letter T. Then I'm just going to create one more key value pair. So this will be for the second rotation, and as you can see now it is rotated to the right, the letter T, and also add the remaining 2 rotations. So this will be the third rotation when the letter T is upside down, and the fourth rotation is when the letter T is rotated like this, so to the left. Okay, the next key value pair I'm just going to add is the color of the letter T, and I'm just going to set the key to color, and this will be from color the thread, so from this model, from the Arcade color model. And also add a number of rotation for this letter. So number of rotations is 4, so we have 4 rotations for the letter T. And one more key value pair I'm going to add is the settled letter. And I'm just going to explain this a little bit later. So technically when the letter is no more active, it is settled on the bottom of the gaming area or the playing area. Its value will become 11. In this section we are going to copy the letter T, its default rotation, to the grid and also draw it. So let's go back to grid and import the letters. So here after the import Arcade I'm going to import the letters. And let's scroll down to the grid class, and I'm just going to create one more property which will be the active letter. So self.activeLetter equals letters.letterT. And now what I'm going to do is copy, as I said, the letter T's initial rotation to the grid. So for that we are going to create one more method, and this method will be called copyLetterToGrid. So copyLetterToGrid, and this returns none. And I'm just going to add a little bit documentation to it. So this copies the active letter to the grid. And first what I'm going to get is the rotation. So rotation or rot equals cell.active letter at index or key 1. So this corresponds to this and holds this two-dimensional Python list. And I'm also going to loop through for y in range length of rotation, and also in an inner loop I'm also going to loop for the x, so for x in range length of rotation at index y. And here I'm just going to ask if the rotation at row and column equals 1, so y and x index equals 1. And also one more if condition: if self.getCell at x plus start x and y plus start y equals 0, then we are going to set the cell value. So self.set cell at x plus start x and y plus start y to value 1. And start x and start y, we defined it a little bit earlier. These are the initial letter positions, so start x is 4 and start y is 1. Okay, so that's all what we have to do in the copy letter to grid. And now let's scroll up, and here in the init method I'm just going to call this method. So self.copy letter to grid, and let me run this file, so the grid.py. And as you can see, now the t is copied to the grid, so here it is. Here is the top part and here is the bottom part of the t, so these are all ones. Now let's draw these. Okay, to draw the t, I'm just going to create one more method, and this will be the draw letters method. So draw letters, and this returns also just none. And here in this method I'm just going to loop through again on the grid height, so for y in range grid height, and also create an inner loop which loops through on the grid width, so for x in range grid width. Here I'm going to do the same calculation I already did for the walls. So the square x will be equal to the x times the cell size, and the square y position will be equal to the grid vertical size minus the cell size minus y times the cell size. And here comes the draw command. But first I'm just going to ask using the getCell function or method. So if self.getCell at xy equals 1, so this is an active letter, we are going to draw it. So arcade.draw lbwh rectangle field, so left bottom width and height, and giving it the square x and square y, so the xy position of the square, the cell size and the cell size, so the width and height, and cell.active letter color, so this will be this key value pair, so the red. And now let's call this draw letters function in the draw all here. So cell.draw letters, and now let me run it. And as you can see, we have the t drawn here. And I'm also going to add one more draw call to actually have this outline for this t. So for that I'm just going back to draw letters, and after this draw call I'm going to add one more draw call, which will be the arcade draw lbwh rectangle, and this time this will be outline. So this will be this was the field and this will be the outline. So also square x, square y, cell size, so xy position of the square and the width and the height of the square. Its color will be arcade color Amazon, and the border width will be set to 2. And now let me run it. And as you can see, now we have separated squares. And as we copied the letter to the grid and we added to x the start x and to the y the start y, if we go up, so start x is 4, start y is 1, if you go here, as you can see, start x goes from left to right, so 0, 1, 2, 3, 4 to this position, and start y is 1, so 0, 1, and it draws the first square at this position, and all the other squares is drawn from relative to this position. In this section, we are going to add a new method called rotate ladder, which will be responsible for rotating the active ladders. So here, for example, I'm just going to scroll here, and I'm just going to create this function here somewhere. So I'm going to call it rotate ladder, and this will return also just none. And I'm just going to add a little bit of documentation to it. So rotates the active letter. And the first thing I'm just going to do is create one more property here in the init method, and this will be the letter rotation, and this will start at 1. So letter rotation equals 1. Let's go back to rotate letter method, and here we are going to, every time when this method is called, we are just going to increase the letter rotation property by 1. And here I'm just going to ask an if condition. So if self.letter rotation is greater than the self.active letter number of rotations, and the number of rotations is, if you go back to the letters, here it is set, the number of rotations for the letter T is 4. So for example, the letter I has only 2 rotations, and letter O has no rotations. So let's go back to grid. So if this is greater than the number of rotations for the active letter, we are just going to set back its value to 1. So self.letter rotation equals 1. And then I'm just going to get the current rotation. So rotation equals self.active letter at the key self.letter rotation. So this will be 1, 2, 3, or 4 for the letter T. And creating a for loop here. So for y in range length of rotation, and also create an inner loop, and for x in range length of rotation at index y. And here we are going to ask one more if condition, if rotation at y and x equals 1, so this is the row and the column, then we are going to set the cell value to 1. So cell.setCell x plus the current x, so the current x will change when we are going to move left or right, but for now it is just set to start x and start y here, so 4 and 1. So x plus current x, y plus current y, and 1. Okay, now let's call this rotate letter method when we press the up arrow key. So let's go back to the game.py, and here in the game view we are going to add one more method to it, which will be the on key press. And as I said earlier, I already explained these methods in my arcade introductory series. So on def on key press, it takes a symbol which is an integer and also a modifiers, and which is also an integer, and it returns none. And here I'm just going to ask if the current symbol is arcade key up, we are just going to call the rotate ladder on the grid. So cell.grid.rotate ladder, which will call this function we just created. Now let's try it. Okay, now I'm going to press the up arrow, and as you can see now it rotates, but it also just overrides itself. Overdraws itself, so we have to create one more method which will clear after each rotation or each movement, it will clear the grid. So let's go back to the grid class, and here after the rotate letter I'm just going to create one more method, and this will be the clear grid, and it also returns none. And I'm just going to add documentation to it. So sets the whole grid to 0 except for walls and settled letters. And I'm just going to loop through on the grid height. So for Y in range grid height and also the grid width, which will be of course an inner loop. So for X in range grid width, and here we are just going to ask if it is not a wall. So if cell.getCell at xy doesn't equals 8, so it's not a wall. In this case, we are just going to set the cell value to 0. So cell.setCell at xy 0. And we are going to call the clear grid before each rotation. So here in the rotate letter, self.clearGrid. And now this should work. So let me try it. And I'm just going to press the up arrow. And as you can see, now it rotates and also clears the previous rotation. In this section, we are going to add movement to the left to our tetromino. And for that, we will need two methods. One will be the try move, so which will check if we can move to the left or to the right, so there is nothing to the left or to the right. And the second method will be the move left method. And in the next section, I'm also going to add the move right method. So let's do the try move method. And I'm just going to add it here. So try move, it takes an X and a Y, which are both integers, and it returns a boolean. And I'm also going to add the documentation to this. So checks if we can move left or right. And here we are going to use the getCell method. So if cell.getCell at xy doesn't equal 0, we are going to return false. So return false. And otherwise, we are just going to return true. So every time when we move left or to the right, we are going to call this try move method, which will check the cell to the left or to the right if it is equal to 0, or if it is not equal to 0. If it is not equal to 0, that means that something is on that cell, so in that case it will return a false. And if the cell value is 0, then it will return true. Okay, now do the move left function or method. And I'm just going to do it after the try move. So move left, it returns none. And here I'm going to use the global current x because we are moving horizontally. So we created this current x variable earlier. So current x is a start x. So it is its start position or its start value is 4. And we are also going to use later the current y when we are going to move down. But for now, we are just focusing on the horizontal movement. So we are going to use this global current x, and I'm also going to create a local variable called breaker. And I will explain why we need this a little bit later. So for now, we are just going to loop through again on the grid width. So for x in range grid width. And here I'm just going to add an if condition. And if the breaker is true, we are going to break out from this loop. And here, after this if condition, I'm going to create an inner loop. So for y in range grid height. And here I'm just going to ask the value for the cell. So if cell.getCell xy equals 1, then we are going to also ask the try move. So if cell.try move x minus 1 and y, so we are moving to the left, that's why we are checking for the minus 1. And if this condition is so we can move to the left, we are going to set the current cell value to 0, and from the current cell value to the left cell value, we are going to set its value to 1. So x minus 1 and y 1. And also going to add an else block here. So if we cannot move, so try move returns false, then we are going to set the breaker to true and break out from the inner loop. And because we set the breaker to true, it will also break out from the outer loop. And here the last thing what I'm going to add to this is outside of these for loops, I'm just going to ask if not breaker, so breaker starts with false. So if it is not false, which means it's true, we are going to add or subtract from the current x minus equals 1. And now let's use this method, so the move left method, whenever we press the left arrow key. So let's go back to the game.py, and here is the onKeyPress method, and here we are going to add one more condition. So elif symbol equals arcade key left, we are going to call on the grid the move left method. So cell.grid.move left. Okay, let's try it. So now I will press the left arrow, and as you can see it moves left. And because I use that try move function or method, it cannot go outside of these walls, so it stops here. I can press the left arrow, but it stops at the walls. And now let me show you something. So let's go back to the try move, and I'm just going to comment out this section. So this if condition, it just always will return true, just to show you what happens. So in this case we are just going to overwrite the walls, which is not correct. Okay, I'm just going to remove the comments here so that it works correctly. And in the next section we are going to add the move right. Although technically we can combine the movement to the left and also to the movement to the right in one method, but I decided to just do it like this. Okay, in this section we are going to add the move right method, which will be responsible for moving the tetrominoes to the right, or the letters. And this will be almost the same as this move left, with very little or slight changes. So here I'm just going to create a new method. This will be the move right, and it also returns none. And I'm also going to use here the global current x. So global current x, and also create a breaker here, like in the move left. And the change is here. For example, now we are going to loop backwards. So for x in range grid width -1, and this is the stop, and this is the step. So we are going to -1 with -1 or -1. Here also going to add the same if condition for the breaker. So if breaker is true, it will break out from this loop. And now let's add the inner loop. So for y in range grid height, and here we are just going to also get the current cell. So if get cell xy equals 1. Now let's check if we can move. So if cell.try move, so if this returns true, so x plus 1, here we use the x minus 1, and here we are using x plus 1, so because we are moving to the right, so the x is incrementing. And I'm just going to add two set cell methods here. So cell.setCell at the current xy, we are going to set the cell value to 0, and set cell x plus 1 y, we are going to set its value to 1. And also going to add the else clause here. So else, if this is not true, we are going to set the breaker to true and break out from the inner loop, and the breaker here will also break out from the outer loop. And do the same lastly here, just outside these loops. If not breaker, we are going to add to current x plus 1. So this with this we can move the tetromino or the letter to right. Now let's try it. Okay, let's move to the right. Although I have forgotten to add this method to the game.py and also ask here for the arcade key right. So here after this one I'm just going to add one more elif. So elif symbol equals arcade key right. We are going to call the grid.move right method, and now let's try it. So let's move right, and of course if I press the button it stops at the wall, and I'm also can rotate it, and it also stops here on the left wall and also on the right wall. But there is still a little problem here. So if I go, for example, to this wall and I press the up arrow, it will still rotate into the wall. So let me show you. I mean here. So as you can see now it rotates to the wall, and the same applies on the right side. If I go like this and press the up arrow, it just rotates to the wall and overwrites the wall. So this is what we are going to solve in the next section. Okay, so let's solve this little problem what we have. I just showed you in the last section. So if I go, for example, here, and if I press the up arrow, it rotates into the wall. And the same applies on the right side. And now if I press the up arrow, it just rotates into the wall. So that's what we are going to solve in this section. Okay, so I came up with this idea that we have the main grid and we will also have a test grid. And when we rotate, we are always going to copy the whole grid from the main grid to the test grid. And after rotation, we are going to check if the main grid's walls or the settled letters were overwritten. If yes, we are going to copy back everything from the test grid to the main grid. And if not, we are just going to move further in the game. So here, after the main grid, I'm just going to create one more property, and this will be the test grid. So self.testGrid equals deep copy, and I'm going to import this function soon. So we are going to do a deep copy of the main grid, and this is a standard Python function. We can import it like this. So from copy import deep copy. And now that we have a copy of the test grid, we are going to create the next method which will check both of these grids, and I will call it check grids, and this will return a boolean. And let me also add a little documentation to it. So check if the walls or settled letters are not overwritten. Okay, as usual we are going to loop through the grid height, so for y in range grid height, and also on the grid width. So we are getting each cell, so for x in a range grid width. And here we are going to ask a condition or check a condition. So if cell.testGrid at yx, so row and column, equals 8, and cell.getCell at x and y doesn't equal 8, so on the test grid it is 8, but on the main grid it is not 8, that means that we have overwritten the walls. So we have rotated some letter into the wall. In this case, we are just going to subtract 1 for the cell.letter rotation, so cell.letter rotation minus equals 1. And also return false. And otherwise, when it doesn't return false, we are just going to return true from this checkGrid function. And I'm going to create one more method for copying the grids, because this deep copy is not the fastest function. As far as I know, I read it somewhere on the internet that you should be cautious with this deep copy because it is a slow function. So I'm just going to create my own grid copy function after this check grids. So here I'm going to call it grid copy, and this will have two parameters, the from grid, which is a list of lists, and the to grid, which is also a list of lists, and it returns none. And let's add a little bit documentation to it. So it copies the data from grid to grid, and it is faster than using deep copy. So what we have to do, of course, is loop through on the grid height, so for y in range grid height, and also on the grid width, so for x in range grid width. And we are just going to set the to grid yx equal to from grid yx. That's all what we have to do for this grid copy. And now let's use these check grids and also the grid copy when we rotate the letter. So let's go back to game.py, and here is the letter rotation. So instead of calling directly here the grid.rotate letter, the first thing I'm just going to do when we press the up arrow is copy. I'm just going to add here comment, so copy main grid to test grid, and for that we are just going to use the method we created a few moments ago. So self.grid copy grid main grid to grid test grid, so from grid, and this is the to grid. And now let's rotate the letter. So I'm just going to add here also comment, so rotate the active letter on the main grid, so self.grid.rotate letter, and here we are going to check if the vowels were overwritten. So check if vowels or settled letters were not overwritten actually with this if condition. So if not, self.grid.check grid, and remember that this returns a boolean. In this case, I'm also going to add here just a comment. If overwritten, then copy the test grid back to main grid. Maybe it is a little bit complicated. Maybe it can be solved with an easier solution, but I don't care. I came up with this idea and it works. So if this returns true, I mean false, so if not false, which means that the vowels or the settled letters were overwritten, in this case we are going to copy back. So self.grid copy back from the test grid to the main grid. Okay, let's go back for a second here. So check grids, we are now only checking for the vowels. Later we are going to add also if conditions to check for the settled letters. And this should already work. Let me try this. So I'm just going to the left wall and rotate it like this. And now let's try to rotate. And as you can see, nothing happens. So the tetromino or the letter doesn't rotate into the wall. Let's try it also on the right wall. And now I'm just going to press the up arrow and it doesn't rotate. If I go to the left a little bit, then I can still rotate. Or if I'm going like this, I can still rotate because it doesn't rotate into the wall. So it only prevents rotation when we are like this. Okay, and remember that here when we check this, if the test grid is 8 and the main grid is not 8, we are setting this self.letter rotation minus equals 1, so we are subtracting, and we are using the letter rotation here in the rotate letter method. And here we are adding, when we press the up arrow, we are adding 1 to it, and here we are setting it back to 1. If the letter rotation is greater than the active letter number of rotations, and we are also using this to get the current rotation, so from the active letter. So that's why we need also here subtracting 1 if the vals are overwritten. Okay, so let me go back to game.py and just quickly go through again. So if we are pressing the up arrow, the first thing what we are doing is copy everything from the main grid to the test grid using our custom grid copy method. So from main grid to test grid. And then we are rotating the active letter on the main grid. So grid.rotate letter. And then we are checking if not self.grid.check grids. Maybe I should give this a better name. Okay, so this returns true or false. So if the vals were overwritten, it will return false. If they are not overwritten, it will return true. So if it is overwritten, then we are going to copy everything back from the test grid to the main grid. In this section, we are going to add the move down method, which will automatically move down the active tetromino or letter. So here, after the move left and the move right, I'm just going to add the move down. So move down, and this returns none. And here we are going to use the global current y, and its initial value is start y, so 1. And the next thing also, we are going to create here a breaker and also loop through on the grid height. So for y in range, grid height -1, -1 and -1, so this is the end and this is the step. And here I'm just going to add this if condition, so if breaker is true, break out from this loop. And the next thing will be to loop through on the grid width. So for x in range grid width, and here we are also going to ask for the current cell value. If self.getCell xy equals 1, we are going to do the try move also, so if it can move down. So if cell.try move x and y +1, so we are always checking downwards, that's why here we are adding 1 to y. And if we can move down, we are going to set the current cell value to 0, and we are going to set the cell value below the current cell to 1. And let's also add an else clause here. So else we cannot move down. We are going to set the breaker to true and also break out from this inner loop. So this will break out from the for x in range loop, and the breaker will break out from the outer loop. And also just add one more if condition outside of these two loops. If not breaker, then we are going to increase the current y by 1, so current y plus equals 1. And if you check the move right or the move left, it is almost the same, but here we are moving downwards, so we are increasing the y value by 1. Okay, let's use this move down function, and as I said, this will be called automatically by the arcade engine. So let's go back to game.py, and here after the onDraw I'm just going to create one more method, which is the onUpdate method. So onUpdate, and this takes the delta time, which is a type float, and this returns none. And arcade will automatically call this function or this method 60 times in a second, so this is 16 milliseconds. And here what I'm going to do is create a timer in the, for now I'm just going to add here a pass and create a property here in the game view init method. So, and I'm just going to call it timer, and it will start with the value 0. So every time when this onUpdate is called, we are going to increase the timer's value by the delta time. So cell.timer plus equals the delta time, and as I said, the delta time is 1 over 60, which is 0.016. Okay, and now let's check if cell.timer is bigger than 0.5, which is roughly half a second. We are going to call the grid.moveDown method. So cell.grid.moveDown. So this will move down the tetromino, and also reset the timer to 0. So cell.timer equals 0. And this should already work. As I said, Arcade will automatically call this function 60 times in a second, or around 60 times in a second. So let me run this. Okay, as you can see, now it moves down. And one more thing, so you can play with this value. I added 0.5, which is, as I said, about half second or 500 milliseconds. If you want to move it faster, you should decrease this value. If you want to move the letters slower, you should increase this value, but I'm going to leave it as it is. So as I said, the delta time by default is set to 1 over 60. So if we divide 1 over 60, we will get 0.016 and 6666 repeating. So it is 16 milliseconds. So if I want to get half a second from this, I'm just going to multiply this by 30 and we will get 0.5. So that's how I came up with this number. And there is still one more problem, of course. If the letter is reaching the bottom, it is still active. I can still move it left or right and also rotate it. So that's what we are going to solve in the next section. When the letter reaches the bottom, it will become inactive. In this section, we are going to add one more method, which will be called settleLetter, and this will be responsible for settling the letter. So when the letter reaches the bottom of the playing area, for example now, it will become inactive, and all these cell values, which are 1s, will be replaced by 11s, so the letter will be no more controllable. Okay, let's do it. So after the move down, I'm just going to create this method, and I'm going to call it settleLetter, and also add a documentation to it as usual. So settle the letter when it reaches the bottom. So for this we will need the global current x and the global current y. So global current x and global current y. And we also have to loop through on the grid height and the grid width. So for y in range grid height and for x in range grid width. Now we are going to ask if the cell value is equal to 1. So if cell.getCell at xy equals 1, we are going to set the cell value to 11. So cell.setCell at x and y to cell.activeLetter and settleLetter. So this is the key. And this corresponds to letters, and the active letter is letter T, and the settled letter value is set to 11. Okay, so let's reset the global x and the global y to start x and start y. So we are resetting them to 4 and 1, and also reset the self.letter rotation to 1. So self.letter rotation equals 1. Let's try it. So if we expand this move down, here is the else clause. So we are breaking out from the inner loop from this x in range grid width. And what we are going to also do here is call the cell.settleLetter. So cell.settleLetter. Let me try this. So now it reached the bottom, and it of course disappeared because we have no logic for drawing the cell values, which has the value of 11, but now it is settled here. So let me print it out. For that we are going to use the prettyprint model, so from pprint import pprint or prettyprint, and here when we settle the letter in the move down method, we are going to prettyprint the main grid. And now let me run it again. And as you can see, if it will reach the bottom, it will print to the console the whole grid. And now let me show you this. And as you can see, now these values have become 11. So this is no more 1. And the 11, this value of 11 comes from the letters and settled letter. Okay, now let's also add logic to draw the number 11. So let's go to draw letters method here, draw letters, and for now we have the logic for drawing the active letters, which values are 1, and also the vowels, which values are, so it is here, which values are 8. So let's go to draw letters and add here an elif statement. So elif self.getCell xy equals 11, this is a settled t. We are going to call these two drawing functions from arcade, so arcade.draw lbwh rectangle field, and also arcade draw lbwh rectangle outline. And this will take the square x and the square y, the cell size, so this is the xy position and the width and the height, and the color will be the letters dot letter t, and the outline will be also square x, square y, cell size, and the color Amazon, and the border which will be set to 2. And now let me try it. And now if it reaches the bottom, it won't disappear, but it also becomes inactive. So now if I press the right arrow, it doesn't move, and if I press the left, it doesn't move, because now its value is set to 11. And we can move only those cells where the value is equal to 1. Okay, add one more function call or method call to this settle letter we just created. And we are also going to copy the next letter to the grid. Although we don't have any next letter, so we'll copy the same letter, the letter T. So cell.copy letter to grid. Let me try it. So let's move this here. And now it creates the new, although it deletes the old one, still. You can see it here in the console. So we should go also to the clear grid and just add one more check here. So this clear grid, and we are only checking for the vowels. We also have to check for the settled letters. So for that, I'm just going to replace this for if condition and add here a new if condition. So if getCell xy not in 8, 11, 12, 13, 14, 15, 16 or 17, so this will be the values for the settled letters, then we are going to set the cell at xy position to 0. So now this should work. Let me try it. And as you can see, now it doesn't clears the already settled letters. In this section we are going to add the remaining letters. So until now we only used the letter T. Okay, so I already copied and pasted all the other letters. So here is the letter I, and the letter I has only 2 rotations, so 1 and 2. So color will be color blue and the number of rotations is set to 2, and when it settles down its value will become 12. And here is the letter O. It has only one rotation, so its color will be color green. Number of rotations is 1, and when it settles down its value will become 13. Here is the letter Z. It has 2 rotations, color jasmine, and number of rotations is 2, of course, and the settled letter will be 14. Here is the letter S. As you can see, it has also 2 rotations. Its color will be African violet, number of rotations, and the settled letter is 15. Here is the letter L. It has 4 rotations. Its value will be color alloy orange, number of rotations, and when it settles down its value will become 16. Here is the letter J. It has also 4 rotations. Its color value will be color amethyst, number of rotations is 4, and settled letter is 17. So we have 7 letters. And now let me try some other letters. So let's go back to grid, and here when we set the active letter, I'm just going to set it to letters or letter I. Let me run it. And now as you can see we have an I which has only 2 rotations. Okay, let's go and let's try also, for example, letter J. And the letter J looks like this, and it has 4 rotations. And one more letter, which is the letter O. Let's try this. And it has only 1 rotation, so we cannot rotate the O. In this section, we are going to add a functionality for randomly choosing a letter. So let's go back to the letters.py, and here we have these 7 letters defined. And I'm just going to add a list which will contain all these letters. So I'm going to call this all letters, and it will contain all the letters. So letter T, letter I, O, Z, S, letter L, and the J. And we are going to use the from the random module, the choice function. So here we are going to import from random the choice function, and here we're just going to create a function, but first I'm just going to add here a comment, so which will randomly pick a letter from all letters list. So let's do this function, and it will return a random letter like this. So return choice and all letters. I have also added the return type, so it returns a dictionary, so all of these letters are Python dictionaries. Okay, now use this function, so choose random letter. Let's go back to grid, and here instead of setting it to a static letter, use the newly created function. So active letter will be equal to letters that choose random letter. And now let's try to run the game. So now it picked the letter S. Let's try it again. Now it picked the letter O. And one more time. And now it is the letter Z. So okay, the random letter picking is working. In this section we are going to add the next letter. So every time when the active letter gets settled at the bottom of the playing area, the next letter will become the active letter. So for that we need one more property here in the grid init method, and we are going to call it next letter. So after this one, I'm just going to create this property self.nextLetter equals none. And make sure that you set the active letter and the next letter before you copy the letter to the grid, because the copy letter to grid uses the self.activeLetter property. And now that we have this next letter, we are going to use this in the draw letters. So let's scroll down. Here is the draw letters, and we only drawing the active letter. So when the value, cell value is equal to 1 and the settled T. So now let's add the remaining letters, and I'm just going to add here a bunch of elif statements. So here I'm just going to copy this. So elif, here was the settled letter T. So elif get cell xy equals 12. This is our settled I, and we just draw it. The next comes a get cell xy if it is equal to 13. This is the settled O. So we draw the O. Elif get cell xy equals 14. This is the settled Z. We are drawing it here. Elif get cell xy is 15. This is the settled S. And this is the settled L when the get cell xy equals 16. And this is the settled J when the xy equals 17. Okay, this was the second step. Now let's go to the third step. For the third step, we have to go to the copy letter to grid, which is here. So expand this method. And here after this for loop, we are going to set the next letter like this. So cell.next letter equals letter that choose random letter, and this will choose the next random letter. And there is one more step, which is the fourth step. So I'm just going to collapse this and go search for the settled letter function or method. Also collapse this. Here is the settled letter, and here we are already setting the letter rotation back to 1, but we also have to set the active letter before we copy. Self.active letter equals to the next letter, and I added here this comment. So do this first, then call the copy method. So this is the copy method, and because the copy letter to grid uses the active letter. So I think that's all. Now it should work. Let me try it. Okay, now it picked the letter T. Now it is the letter S. Okay, now it is the letter I. It already starts to work, although this has still some little bugs, what we are going to solve later. So as you can see, now it works. So one problem is still that we can rotate to already settled letters. Let me show you. For example, here I'm just going to rotate like this, and as you can see, it rotated to the already settled letters. Or for example, here, if I go like this and I press the up arrow, it just rotates to the already settled letter. So that's what we are going to solve in the next section. In this section, we are going to add some more checks to the checkGrid method to prevent rotating into already settled letters. So here, when we press the up arrow in the onKeyPress method in the GameView class, we already do the grid copying from main grid to test grid. We are rotating the letter and we are checking if the vowels were overwritten. So here, let's go to this checkGrid method, so to the grid class, and here it is. So, and as you can see, we now only checking for the vowels. So if cell.testGrid yx equals 8 and cell.getCell at xy doesn't equals 8, that means we have overwritten the vowel. So in that case, we are decreasing the letter rotation by 1 and returning a false. So let's add few more else or elif checks for checking, for example, the letter T, which value is 11. So I'm just going to copy this. So elif cell.testGrid yx equals 11 and cell.getCell at xy doesn't equal 11, we do the same, so self.letter rotation minus equals 1 and return false. And 11, if we go to the letters, it is for the letter T, the settled letter. And let's do this for the remaining letter. So I'm just going to copy all the elif statements. So here we are checking for the 12, and the 12 is the letter I, so settled letter 12. And here is for the number 13, which is letter O, and number 14, number 15, I mean here, number 16 and number 17. So these corresponds to this. So letter O, settled letter 13, letter Z, settled letter 14, here is the letter S, which is 15, letter L, which is 16, letter J, which is 17. So now it should work. Let me try this out. So here, for example, I will try to rotate now, and as you can see, it didn't rotate it. Or let's try to rotate now. Of course, it still had space to rotate, and as you can see there we have another problem what we are going to solve in the next section, but let's just try the rotation for now. Let's try to rotate when we are, for example, here, or for example here. Okay, as you can see now it prevents the rotation when it overrides the walls or also the settled letters. In this section we are going to solve one more problem what we have, so let me show you the problem. So for example now, and as you can see we have this letter L, but when it settled down it still moved this part one cell down. Until now we are only checking cell by cell, so we are going from top to bottom and left to right as we loop through the grid. So we are going like this, the next row, the next row, the next row, and when the loop reaches this part, so it goes from left to right like this, when it reaches this cell it still checks if the cell below is 0. So yes, it is 0, so it moves this cell one cell below. And we should actually check for the whole letter, not just the individual cells. So we are going to create one more method, and this method will be called something like can whole letter move down or something like this. And that method will check if the whole letter as a whole can move down, not just its individual parts. And the same happens if I try to place this I rotated like this. As you can see, its first letter, I mean its first part, went still down one cell. Okay, so let's go to the grid.py, and here we are going to create the can whole letter move down function. So after the check grids, I just going to copy this. So can whole letter move down, and this actually returns a boolean, and I'm just going to add a little documentation to it. So checks if the letter as a whole can move down, not just its parts. And we are going to create here a list, so letter can move list, and of course we are going to loop through on the grid height, going from up down. So for y in range grid height -1, -1, -1, so we are going from the top to bottom. And here also let's do the inner loop for checking the x, for x in range grid width. And here we are going to ask if the current cell is 1. So if cell that gets cell xy is 1, we are going to add another inner condition. So if cell that gets cell x and y plus 1 equals 0, so we have an empty cell below the current cell, or cell that gets cell x y plus 1 equals 1. That means that we have an active letter cell below. We can still move if it is equal to 0 or if it is equal to 1. So in this case we are just going to append to the letter can move a true value. And else, if this condition is not true, we are going to add to the letter can move a false value. Lastly, we're just going to return all letter can move. So letter can move will hold either true or false values, or combine true or false, and this all makes sure that it is only returns true if all letter can move is true. So each of these values have to be true in order to return true. If either of these values is false, this all will return false. Okay, now let's use this method in the move down method. So here is the move left, move right, here is the move down, and I'm just going to add here a little documentation. If the whole letter cannot move down, then we are going to settle the letter, also clear the full rows and return. So here we are just going to make this condition. So if not self that can whole letter move down, we are going to settle the letter here and just return from this move down function. So it will not continue to this. And here we can comment out or delete this cell that settle letter in this inner loop, because now we are doing the settling here. This means that if the whole letter is not able to move down, then we can already settle the letter. And we are going to do also the clearing of the full rows also here. And now let's try to run this. And okay, so now as you can see, it didn't move. So it now moves, the whole letter moves as a one whole, instead of just individual parts. In this section we are going to add the method for clearing the full rows. So here, after, for example, clear grid, I'm just going to create this method. So, and I'm going to call it clear full rows, and this actually returns none. And I have also added a little documentation to it, so it clears the full rows, although this function is pretty self-explanatory, its name. Okay, now let's create a local variable, and this will be the y, just y. And the y will be equal to grid height minus 1, and the grid height is 15, so this will be, its value, y's value will be 14. And here I'm just going to create a while loop. While y is greater than 0, I'm going to create another local variable, but this time this is local to the while, so counter equals 0. And here we are going to loop through the width of the grid, so for x in range grid width, and here we are going to check for the walls and also for the settled letters. So if cell that gets cell xy doesn't equals 8, so the wall, so it is not a wall, and cell that gets cell xy is greater than 10, which means there is a settled letter. So remember, the settled letters are the 11, 12, 13, 14, 15, 16 and 17. So if it is a settled letter and it is not a wall, then we can add to the counter or increase the counter by 1. So counter plus equals 1, and that's how we are going to count if we have a full row or not. And the next step will be to actually check if we have a full row. So here, after this for loop, I'm just going to add if counter equals 10, and I'm just going to show you something why it is 10. So if I run the game, as you can see, we have 10 cells. So Horizontally we have 12 cells, but we are not counting the two walls, so this wall and this wall, so we have 10 cells. So this means if counter is 10, that we have a full row. And I'm just going to add one little documentation also here. So when counter is 10, we have a full row. And in this case, we are just going to loop backwards from the current row. So I'm just named it YY. For YY in range, the current row, which is Y, that's why I named it here YY, because Y is already taken. And let's go back to 1 with a step of -1. So if, for example, if it finds a full row at row 12, it will go back from 12 to 1 by -1. So 12, 11, 10, and so on. So we are looping from the current row upwards, and we are also going to loop through the width of the current row. And here we are going to check if cell.getCell XXYY, if it doesn't equal to 8, we are going to get the current cell value, so cell above, or not the current, but the cell value above with this. So cell above equals cell.getCell XXYY -1. Okay, now that we have the value from the above cell, we are just going to set the current cell's value to the above cell value. So cell.getCell XXYY to cell above. And we are also going to set the above cell's value, so cell.getCell XXYY -1 to 0. So here we just move down everything by 1. So if the above cell's value is 2, it will set the current cell value to 2, and the above cell value it will set to 0. Okay, I hope that this is understandable. And okay, so the last, or not the last thing, but almost the last thing will be here in the counter. So if counter is 10, we are just going to reset the Y. So Y equals grid height -1, and this way the Y cycle or the Y loop will start over from 14. So it will start again looping from 14 down to 0. And if we haven't found any full row, we're just going to decrease Y by 1. Okay, so technically this while cycle will run every time over and over again until it finds full rows. So if we have one full row, it will run on only once, and if we have, for example, 2 or 3 full rows, it will start over from the top and going down, and always check for those full rows. And here it will just go from that full row upwards and set everything down one cell, or move everything down one cell. And here we just resetting the Y to start again over, and if there is no full row, then this will never reset, so we are just going to decrease Y by 1, and sooner or later Y will be not bigger than 0, so it will be either equal to 0 or less than 0, so this Y cycle will stop. Now let's try this, clear full rows, and this we are going to add here in the move down method. So here we are checking if not can whole letter move down, we are going to settle the letter, and also going to clear the full rows and then return. Okay, now let's try it. It should already work. I'm just going to play a little bit until I have a full row. So here we are very close to have the first full row, and tough. As you can see, it cleared the full row and it moved everything down. So let me do it again. For example, So here I'm just going to have the next full row, as you can see, and moved everything down, and the next full row, as you can see, now it moves only the full rows. I mean, clears the full rows and moves everything down which are above the full row. So it looks like it works as it should. And just to show you that of course it works when we have multiple full rows, I'm just going to show you how it looks like. So here we have two full rows, and it clears both of those rows, and it just moves everything down to the bottom. In this section we are going to add some states to our game, and these states will be the pause state, the playing state, and the lost state. So here in the game.py I'm just going to import from the enum module the enum class and also this auto class. So from enum import enum with a capital E and also this auto function. And here I'm just going to create a class state after this window creation. So class state, and this will inherit from the enum. And I'm going to create 3 states. So when the game is in the pause state, when the game is in playing state, and when the game was lost, so it is in the lost state. And here in the GameU class, in the init method, I'm just going to create a new property which will hold the current state. So self.state will be equal to states.playing. So when we start the game, we will automatically enter the playing state. Okay, so now the next thing what we are going to do is here in the onKeyPress method, we are going to add some more checks. So for example, if the symbol is arcade key up, so we are pressing the up key. Here we are going to add one more check after this. So if symbol is arcade key up and the state is states playing, so only rotate the letters when the state is playing. So if the state is, for example, pause, we don't want to rotate the letters. And do this also for the key left and also for the key right. So here is the key left. So if symbol is arcade key left and the state is states playing, only then move the current active letter to left. And also apply this to the right. So if symbol is right and the state is states playing, move the active letter to right. And I'm just going to add one more key press event, which will be the P key. So elif symbol is arcade key P. Here we are going to set the pause state. So I'm also going to add a nested if. So if state is states playing, we are going to switch it to pause. So set the state to states.pause. And of course, else, if the state is not playing, so it is already paused, we are going to set it back to playing state. And now we have a simple mechanism to pause the game. Let me show you this. Although before I run the game, I'm just going to add one more state check here in the onUpdate. So do this only when the state is playing. So if self.state is states playing, then increase the timer and check for the timer's value. So if it is set to pause, it will not do this part. So now let me show you. So if I press the P, I can now pause the game. If I press again, it will continue where it left. So for example, let me try here, press the P, now we have paused, and if I press a P again, it will continue. And later, as we are going to draw the UI text or elements, here in the onDraw we are also going to check if the states is in pause or in playing. If it is in pause, it will display that game is paused. But I'm just going to do it later when we are going to draw the text. In this section we are going to add the functionality for accelerating down. So if I press the down key, I just want to move those letters, those active letters, to move faster. So here in the GameUV-init method, I'm just going to add one more property, and this will be the self.down key held. So if we are holding down or not holding down the down key. So, and of course it starts with a value of false. And the next step will be here in the on key press. I'm just going to add one more check for the down key. So after key right, for example, elif symbol is arcade key down and we are in the playing state, then I'm just going to set the down key held to true. And when we release, of course, the down key, we want to set it back to false again. So for that, we are going to need the on key release method. And I'm just going to create it here. So on key release, and this takes the symbol as an integer and the modifier, which is also an integer, and this returns none. And this will be automatically called by arcade when we release a key. So here we're just going to set back the down key to false. So if symbol is arcade key down and we are in the playing state, we are going to set back the down key held to false. So here in the on key press, we are setting it to true, and in the on key release we are setting it back to false. And as I said, this gets automatically called by the engine itself. Okay, now let's go to the on update, and we are going to use this property here. And I'm just going to here add for this if condition. So if the down key is held and the self.timer is bigger than or equal to 0.05, so if these both are true, we are going to accelerate, so we are going to call the grid move down and set back the timer to 0. And now let's add an else clause if we are not holding down the down key. And we are just going to do what we had before. So here we are going to add if self.timer is bigger than 0.5, we are going to move everything with the normal speed. So self.grid move down and self.timer equals 0. So here we are accelerating downwards. So we are setting it to 0.05 when the down key is held, and when the down key is not held, then this if condition will be true and it will move with the normal speed. Okay, so let me try this. Okay, now I'm going to press the down key, and as you can see, it accelerates the active tetronemo downwards. With this, the game is a little bit more interesting. We can play much faster. In this section, we are going to add the game over or the game lost state. So when this happens, so we have a full grid, I just wanna set the game over state or the game lost state. And in this case, of course, it will display the text game over, press space to restart, but that we are going to do in the next section. So for now, let's go back to the grid.py, and here in the grid class, I'm just going to create one more property, and this will be the self.gameover, and this will be a boolean, and its value will start with false. And we are going to set its value, so the game over's value, to true when we cannot copy more letters to the grid. So, and the grid copy letters is happening here, so copy letter to grid. So in this method, the copy letter to grid, to this if condition, I'm going to add an else clause, and in the else clause, I'm just going to add a little documentation to it. So If a letter cannot be copied, it's a game over or game lost state. And in this case, I'm just going to set the property game over to true. So here we are checking if get cell x plus start x and y plus start y equals 0, so the current cell is empty, we are setting its value to x start x, y start y to 1. So we can copy the current into the current cell because it's empty. But if we cannot copy, so if this is false, so it is not 0, but for example 11, 12 and so on, so some settled letter, then we are going to execute this else clause and set the game over to true. Now let's go back to game.py and we are going to set the states to lost if the game over on the grid is true. And we are going to set it in the onUpdate method. So here in the onUpdate, after this if condition, I'm just going to add one more if condition, and this will check for the game over property. So if self.grid.gameover is true, we are going to set the self.state to state lost. And of course, if the state is not playing, it means that it won't execute all of these. It won't execute the on key press event because everything has to be playing. Now let me try it. It should already work. And I'm just going to lose the game. And as you can see, it just stopped. I can no more move the letters. And in the next part, I'm just going to add some text here to display that it is a game over and press space to restart. In this section, we are going to draw the game over text and also the press space to restart text when the game is lost, so when the state becomes lost. And of course, we are going to the GameViews onDraw method, and here I'm just going to add first for the game pause state, I'm just going to add here an if condition. So if the cell.state is states pause, so we pause the game, we are going to use the arcade's draw text functionality, so arcade.draw text, and I'm just going to draw the text game paused at this location, so x 256, y 480. The text color will be arcade color yellow and the font size will be 40. So let me try this. And if I press the P, now it shows this text game paused. And if I press the P again, of course, I can continue the game. Okay, so this was for the states.pause. Now the next thing will be for the lost state. Also here in the onDraw method. So elif cell.state equals states lost. First, I'm just going to draw the game over. And I'm just going to set here, going back to the grid, and just going to set this game over to true, and later also, of course, set it back to false, because now I just want to test it. And let me see. Okay, now as you can see, it draws this game over. Now let's also draw the press space to restart. After this, so arcade draw text, press space to restart, and in this position, so 256 plus 48 on the X, 440 on the Y, arcade color aero blue, and the font size will be 15. So let me show you. Okay, now it draws the game over text with this bigger font, and the press space to restart with this smaller font. And if the grid is full, it will be barely visible, so I'm just going to add a rectangle to it. So before we draw the game over text and before we draw the press space to restart, first we are going to draw a rectangle. So arcade.draw lbwh, so left bottom width and height rectangle field, and in this position, so 256 minus 128, 480 minus 70, so for 410. Its width will be 512, its height will be 140, arcade color Yankees blue. If you want, you can also just remove this minus and just give it 128, and here also 410, but I think I like it as it was, because I know that it is relative to this game over, so 256 and 480. Okay, so let me show you how it looks like. Okay, now we have this rectangle. Of course, you can play with these values, and I think you should play with these values to suit your needs. I'm just going to leave them as it is now. And also don't forget to set back in the grid.py this game over state or this game over property to false. In this section, we are going to draw the user interface text. So here in this part, in this right part, we are going to draw the cleared rows, or the number of cleared rows, the next letter, and also some other text here. So let's go to the GameU class, and later I'm also going to explain why it is giving this performance warning. But for now, let's go here, and we are going to work in the onDraw method. And the first thing what we are going to draw is the text number of cleared rows. So here in the onDraw method, I'm just going to add one draw call, so arcade.draw text, and this will display the cleared rows text at the position 832x and 840y, and its color will be aero blue, and its font size will be 20. So now let me see. As you can see, now it is displaying here the cleared rows. So let's add also the counter, which will show how many cleared rows we have. So for that, first we have to go to grid.py, and here we are going to create one more property, and this property will be the cleared rows, and it will start with 0. So, and we are going to increase these every time when we clear a row. And where we are clearing the row? In the clear full rows method, so here. And if the counter is 10, so we have a full row, here we are also going to increase this cleared row property. So after this, so cell.cleared rows plus equals 1. And that's all what we have to do in the grid. So let's go back to game.py, and here we are going to display after this. So let me just paste here arcade.draw text, and as a string cell.grid.clearRows property at xy, so 896, y 800, also aero blue, and the font size will be 25. So let me show you. I'm just going to create a full row. Now as you can see, it displays cleared rows 0, and if this letter settles, now cleared rows is 1. Let me show you one more example, and now it is cleared rows 2. Okay, the next text what we are going to draw is the next letter text. So draw text, next letter at this position, with this color and this font size. So here we are going to draw the next letter later a little bit. And last two text what I'm just going to add here are these. So press P to pause at this position, color and font size, and press escape to exit. And I'm just going to add one more check in the on key press event. So let's scroll down or up to the on key press, and I'm just going to add here, if the symbol equals arcade key escape, we are just going to call the arcade.exit function. And if I run the program now, and if I press the escape key, first of all we are drawing here the press P to pause, and press escape to exit. So if I press the escape key, now it exits the game. So okay, now let's take a look on this warning in this output. So it says that performance warning, draw text is an extremely slow function for displaying text. And also scroll here, consider using text objects instead. So this is what we are going to do in the next section. We are going to improve the text drawing. In this section we are going to improve the text drawing. So the clear draws, the next letter, and this text. Okay, so as you can see, we have this performance warning when we are using this draw text function. So these, and it says that it is an extremely slow function for displaying text, and you should consider using the text object instead. So we are going to refactor this draw text into using a text object. So for that, we are going to this init method in the game view, and here we are going to create this text object. And the first text object will be the cleared row text. So cell.clearedRows text will be equal to arcade.text. So this is the text object with the capital T, and the cleared rows, so the string to display at the position XY, the color, and the font size is 20. So now we can comment out this and draw it using this text object. So like this, cell.clearedRows text.draw, and this will look the same. And let's do this for the remaining text. So I'm just going to actually comment out everything which has this draw text function, and go back to the init method, and let's create the remaining text objects. So the next will be the cleared rows number text. So this will display the number, so arcade text, and initially it will be 0, and XY position also aero blue, and the font size will be 25. So let me draw this. Here after the cleared rows text, I'm just going to draw the cleared rows number text, but we have a problem here. We don't update the numbers, so I'm just going to create a full row. And for example, now, as you can see, the cleared rows will be still 0 because we are not updating this text. So for that, what we are going to do before we draw this text object is always set its text property. So cell.clearedRows number text equals the string of cell.greet.cleared row or cleared rows. Okay, now it will actually update the text. Let me show you. Okay, for example, now it will update this to 1, and also, for example, now it will update it to 2. So it works. Okay, the next thing what we are going to draw is the next letter text. So let's go back to the init method, and here after this let's create the next property. So this will be the cell.nextLetter text, also arcade text. This will display the next letter text at this position XY, also aero blue, and with this font size. So let me draw this after this, and here it is. The last two text what we are going to draw, I'm just going to copy both of them. So this will be the press P text, press P to pause, XY position, also aero blue, font size 15, and the press escape text, so press escape to exit, XY position, and also aero blue, and also the font size is 15. And let's draw these two texts. So here, self.press P to text draw, and self.press escape text draw. So now we have everything back, but we have improved it to use text objects instead of this draw text function. And as you can see, the XY position and also the color and also the font is the same as we used here in the draw text, so everywhere. And the last thing what I'm going to do is improve it even more a little bit using Pyglet batches. So using batch drawing, you can remove these draw calls. So we have here 1, 2, 3, 4, 5 draw calls. So we can just add one draw call using a batch and draw everything at once. So for that, let me scroll up and let me import from the Pyglet library. So from Pyglet.graphics, import the batch. And as I said, Arcade is built on top of Pyglet. Okay, let me scroll down and let me create a batch property here. So self.textBatch equals batch. And when we create this text object, we are going to set their property. So if you add b here, it will show you that it has a batch property, each of these text objects. So we are going to set the batch to self.textBatch. And also going to do this for each of these text objects. So batch equals self.textBatch, also here, and here. And now we should also comment out just these and add here the self.textBatch.draw. But we have still the same problem as we had earlier. We still have to set these. So I'm just going to copy this line. So every time when the number increases, we are going to set the clear rows number text property to string self.grid.cleared rows. So and now it should work. And as you can see, we have only one batch draw. We don't need all of those extra draws. And as it will settle, now as you can see, the cleared rows is 2. Although as you can see, as I have paused the game, it still gives us this performance warning, draw text, blah 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 blah. This is because here, if the state is state pause, we are still using the arcade.draw text. And also if the state is state lost, we are still using this arcade.draw text. But I'm going to leave it as it is. It doesn't matter because it only uses this function when we are in the pause or when we are in the lost state. If you want, you can also add these, you can also create a text object for this and draw it here. But I'm going to leave it as it is. So as you can see now, we have significantly increased not just the readability, but also the performance. So by using this batch drawing, so only one draw call for each of the text. In this section, we are going to draw the next letter, which is already chosen when we copy the active letter to the grid. So and the next letter, of course, will be here after this text. And it will make the game a little bit easier to play so that you can plan your moves, because you already know which letter will be the next. Okay, so here in the grid file and the grid class, we are going to create one more function, and I'm just going to put it somewhere here after these draw letters, and this will be called draw next letter. So draw next letter, and this returns none. Okay, I'm just going to add a little documentation to it, although its name is self-explanatory. So it draws the next letter on the UI section, so on the right part. And here we are just going to loop through for y in range self.next letter at key 1. So this is, for example, if the next letter is letter T, then key 1 is this. Okay, and also we have to create an inner loop for the x. So for x in range length of self.next letter, also key 1, and at index y. And here we are going to add an if condition. So if self.next letter at key 1 and yx, so row and column, equals 1, we are just going to do the calculation for the square's position. So square x will be equal to x times 64 plus 32 plus 790. And of course you can play with these values to suit your needs. And the square y will be equal to 960 minus 512 minus y times 64 plus 32. Okay, so now we calculated the square x and the square y. We can draw the letters. So first I'm just going to draw the LBWH rectangle field, so left, bottom, width and height. And of course square x, square y for the position, and width will be 64 and height will be also 64, although I'm just going to change this to size. And here is the color, so self.next letter and the key color. And also draw the outline. So Arcade draw LBWH rectangle outline, and it has the same parameters as the field, but we also added the last parameter, which is border width equals 2. And now if I run the game, although I still have to call this method, so draw next letter and in the draw all. So after the draw letters, we are going to call the cell the draw next letter. And now the next letter will be visible. Let me try this. As you can see, the active and the next are the same now, but okay, now it has changed to this O, now it is I, and so on. So now it should be a T, of course, and then this letter, and now another I. So as you can see, it works. Let me show you quickly how the next letter is being created. So here we created this property next letter, which starts as none. And when we call the copy letter to grid, it will actually copy the active letter to the grid, and it will assign to next letter the letters that choose random letters. So the next letter will be no more none. And of course, when the settle letter function or method runs, it will also set the new active letter to the next letter, and it will call again the copy letter to grid, which will also create, which will copy the active letter to grid, and it will create a new next letter, or randomly choose a new next letter. In this section, we are going to add a restart method to our grid. So every time when we lose the game and it's a game over state, we will be able to press the space key and restart the game. So for this, let's go to the grid.py, and here we are in the grid class. And I'm just going to add the last method to this class. And I'm just going to call it restart. So restart, and this returns none. I'm just going to also add a little documentation to it. So reset everything to its initial value. Okay, so the first thing what we are going to do is get the global current x and the global current y variables and restart their values to start x and start y. So current x and current y equals start x and start y. The next thing will be to call the clear the grid, but we are going to modify this method to take a boolean parameter. So cell.clear grid, and I'm also going to set the active letter to a new random letter. So cell.active letter equals letters that choose random letter. Also set back the next letter to none. Also set back the letter rotation to 1. So cell.letter rotation equals 1. And now let's copy the active letter to the grid. So copy letter to grid, and remember that this method should be called after we set the active letter, because it copies the active letter to the grid. And it also sets the next letter. So this should be after these two. And let's set back the game over to false. And also let's set the clear draws to 0. So set.clear draws equals 0. And now let's add this initial parameter to this clear grid method, this boolean parameter. So the clear grid is here. I'm just going to expand this. and I'm going to add a default parameter after the self, and this will be all cell equals false. So by default we are not going to clear all the cells, only when the game state is game over. So that's when we want to clear all the cells, including the settled letters. So here in this for x in range, we are going to ask one more if condition like this. So if all cell is true, clear everything on restart except for walls. So if this all cell is set to true, we are just going to do it like this. So if cell that gets cell xy doesn't equals 8, we are going to set everything to 0. So we are still have to skip the walls, we don't want to clear the walls. And if all cell is not true, so by default it is false, we are going to add here an else clause and move this if condition inside the else clause. So again, if all cell is false, we are just going to execute this else clause and do the regular cleaning. So clear everything except for the walls and the settled letters. If all cell is set to true, we are going to clear everything except for the walls. Okay, so clear grid is now ready, and we should also call this restart method when we press the space key. So let's go to the game.py, and here in the game view class I'm just going to collapse this and go to the on key press. Let's expand this, and I'm just going to add one more elif check here. So elif symbol equals arcade key space, and the state is set to state.lost. In this case we can call the grid restart method we just created. And also I'm just going to set back the state to states playing. So cell.state equals states playing. And that's all. So actually we have finished the game. So let me just try this out. And I'm just going to close the game. Okay, it's now game over. So it says press space to restart. Let's press the space. And it restarts the whole grid, although here is still some bug. Okay, I found it. This else clause should be here, so it is a part of this if condition. So if not all cell, we are going to execute this part. So that was causing that the grid wasn't cleared correctly. And now let me try this. Okay, let me lose the game first. Okay, press space to restart. Now it creates or clears the grid. It randomly picks a new letter, and the rotation also works. Okay, so it looks like we have finished the game. In this video, which is a little bit more than 2 hours long, we have learned how to create a Tetris game in Python using the arcade library version 3.3.2. There are still some parts which can be improved. For example, drawing the grid lines, and also the walls should use shape element lists instead of drawing them one by one. And using shape element lists would significantly reduce the draw calls and also improve performance. But I'm going to leave it as it is. If you want to learn more about shape element lists, I have a video on that topic here on this channel. So if you found this video useful, please give it a like, and if you have a few seconds, then leave also a comment. It doesn't cost you anything, but it is useful for the YouTube algorithm, and it also motivates me to create more of these videos. As I said in the intro, the source code from this video will be uploaded to my Patreon page, and the link to my Patreon will be in the video description. I'm going to show you a few more seconds of the gameplay, and also thank you for watching, and I wish you a very nice day.